During the Bronze Age, metal scarcity prompted societies to develop recycling systems that transformed discarded artifacts into new forms of utility. This process involved melting down statues, tools, and broken weapons to extract usable metal for coinage and construction. The economic impact was significant, as recycled materials reduced the need for mining and allowed for controlled distribution of resources. Material composition analysis shows that recycled bronze contained up to 75% reprocessed metal, indicating a sophisticated understanding of metallurgy. This is Elias Untold Vance. The Bronze Age, spanning roughly 3,300 to 1200 BCE, was defined by the widespread use of bronze, an alloy primarily composed of copper and tin. However, this technological leap depended on a fragile equilibrium between resource availability and societal demand. Tin, in particular, was a rare commodity, concentrated in geographically isolated regions such as Cornwall in Britain, the Iberian Peninsula, and parts of Anatolia. Copper, while more abundant, required extensive mining operations that strained labor forces and environmental stability. The result was a systemic scarcity that forced societies to confront the limits of their material world long before industrialization imposed similar constraints. To sustain metallurgical production without exhausting finite resources, ancient civilizations developed intricate recycling systems. Archaeological evidence from sites across the Mediterranean, Near East, and Central Europe reveals a pattern of deliberate artifact repurposing. Bronze statues, once central to religious or political iconography, were frequently dismantled and melted down for their metal content. Tools and weapons, particularly those damaged by wear or obsolescence, were similarly collected for reuse. This practice was not merely pragmatic, but embedded in economic structures that prioritized resource conservation. For instance, the Minoans of Crete, known for their advanced trade networks, appear to have maintained centralized repositories where bronze objects were systematically assessed, categorized, and redistributed as raw material for new production. The technological mechanisms behind this recycling process involved a sophisticated understanding of metallurgy. Early smelting techniques, while rudimentary by later standards, allowed for the separation of copper from tin in alloys, enabling the purification of metal for reuse. Crucibles made of clay or stone were used to melt down artifacts at high temperatures, often exceeding 1000 degrees C. The resulting molten bronze was then cast into molds to produce tools, weapons, or even decorative items. This process not only extended the lifespan of individual objects, but also reduced the need for large-scale mining expeditions, which were both economically and logistically demanding. Economically, this recycling system functioned as a form of controlled resource distribution. In many Bronze Age societies, metal was a currency in itself, with standardized weights and shapes determining its value. The melting down of older artifacts to create new ones ensured that surplus metal could be reallocated to regions experiencing shortages or to fund state-sponsored projects such as fortification construction or agricultural tool production. This system also created a feedback loop. The demand for bronze objects generated by trade or warfare would, in turn, necessitate their eventual disassembly and reuse. Sociologically, these practices reflected a utilitarian ethos that prioritized collective survival over individual ownership. The destruction of statues, often symbols of power or divinity, was not merely an economic act, but a demonstration of societal priorities. In some cases, religious objects were repurposed into secular tools, indicating a shift in cultural values during times of crisis. Similarly, the redistribution of melted bronze to common laborers or military units underscored the role of metallurgy in maintaining social hierarchies and state authority. By the late Bronze Age, these recycling systems had become so entrenched that they influenced the design of artifacts themselves. Objects were often crafted with future disassembly in mind, featuring standardized components that could be easily separated and melted down. This foresight suggests a level of planning rarely attributed to pre-industrial societies. Yet, despite these innovations, the eventual collapse of Bronze Age economies, marked by events such as the Sea Peoples invasions or the decline of trade networks, would later expose the vulnerabilities of this system. Resource scarcity, though mitigated by recycling, could not be entirely eradicated, and the transition to iron metallurgy would eventually render bronze-based economies obsolete. This is Elias Untold Vance. The mechanisms we've explored today, the technological ingenuity, economic strategies, and sociological adaptations, form a critical lens through which we can analyze the hidden architecture of ancient civilizations. To understand how these systems shaped human history, continue following this channel as we dissect the next layer of untold history. The technological processes underpinning Bronze Age metal recycling reveal an intricate interplay between metallurgical innovation and economic pragmatism. Archaeological evidence from sites across the Mediterranean and Near East demonstrates that ancient societies employed high-temperature furnaces, often constructed with refractory clay linings, to achieve the molten state necessary for reprocessing. Bronze. These furnaces, capable of reaching temperatures exceeding 1000 degrees C, were strategically positioned near sources of fuel, such as charcoal and limestone, which acted as fluxes to lower the melting point of the ore and remove impurities. The presence of slag layers in metallurgical workshops further confirms the systematic approach to refining recycled metal, with workers employing techniques like cupellation to separate base metals from precious ones. Material composition analyses of Bronze Age artifacts, conducted through X-ray fluorescence and lead isotope tracing, reveal a startling statistic. Up to 75% of bronze objects dated between 1200 BCE and 800 BCE and 800 BCE contained reprocessed metal. This figure underscores the scale of recycling networks that spanned regions, as fragmented tools, broken weapons, and worn statues were collected, melted, and repurposed into new forms. The consistency in alloy composition, typically a ratio of copper to tin between 15% and 20%, suggests standardized protocols for remelting, indicating a level of technical expertise that defied the limitations of pre-industrial technology. Economically, this practice mitigated the scarcity of tin, a critical but geographically dispersed component of bronze. By repurposing existing artifacts, societies reduced reliance on long-distance trade routes that transported tin from distant sources like Cornwall or Afghanistan. This localized recycling also minimized the environmental degradation associated with mining, preserving natural resources while sustaining production. Sociologically, the process necessitated specialized labor, with distinct roles emerging for metalworkers who oversaw melting operations and artisans who molded recycled bronze into utilitarian objects or ceremonial items. The reuse of materials from deposed statues or abandoned weapons further reflects a cultural attitude toward resource conservation, where the value of metal transcended its aesthetic or functional use, embedding economic efficiency within societal norms. The technological sophistication of these practices challenges assumptions about pre-modern societies as technologically primitive. Instead, they reveal a deliberate, large-scale system of material management that prioritized sustainability and adaptability in the face of resource constraints, a mechanism as advanced in its context as any modern recycling initiative. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. Economic implications of recycled bronze production during the Bronze Age reveal a sophisticated system of resource management that transcended mere survival strategies. By repurposing existing bronze artifacts, whether ceremonial weapons, decorative objects, or functional tools, ancient societies mitigated the need for extensive mining operations, which were both costly and environmentally disruptive. This practice reduced labor expenditures tied to quarrying and smelting, redirecting human capital toward other productive endeavors such as agriculture, infrastructure development, and administrative record-keeping. The controlled redistribution of recycled bronze also enabled elites and governing bodies to regulate access to valuable materials, consolidating power through monopolization of metallurgical expertise. Archaeological evidence from sites across the Mediterranean and Near East indicates that workshops specializing in metal recycling operated alongside primary smelting centers, suggesting a stratified economic hierarchy where raw material extraction was subordinated to the refinement and reuse of existing stockpiles. This system allowed civilizations like those of Minoan Crete or the Hittite Empire to sustain urban growth even during periods of mineral depletion, as recycled bronze maintained consistent supply chains for essential items such agriculture, tools, military hardware, and trade goods. The economic stability derived from this practice is further underscored by the uniformity of alloy composition in recycled artifacts, which reflect standardized smelting techniques and quality control measures, indicators of a centralized or semi-centralized metallurgical infrastructure. By prioritizing reuse over extraction, these societies effectively decoupled economic expansion from the volatility of natural resource availability, laying the groundwork for long-term socio-political cohesion. The technological efficiency required to melt down and recast bronze without compromising its structural integrity also highlights an advanced understanding of thermodynamics and material science, demonstrating that ancient economies were not merely reactive to scarcity but proactively engineered solutions through metallurgical innovation. This approach not only minimized economic disruption, but also reinforced social hierarchies by embedding control over metal recycling within specialized artisan classes, whose expertise became a cornerstone of economic policy. The interplay between technological capability and economic strategy during this era thus underscores the Bronze Age as a period marked by deliberate resource management, rather than passive adaptation to environmental constraints. The systematic repurposing of bronze artifacts across the Bronze Age is not merely an anomaly, but a defining feature of metallurgical practice in regions where copper and tin, critical components of bronze, were geographically constrained. Archaeological excavations at sites such as the Hittite capital of Hattusa in Anatolia reveal layers of slag deposits, intermingled with fragments of broken statues and ceremonial weapons, all dating to the late Bronze Age. These materials were not discarded, but systematically collected, melted down, and recast into new forms. Analysis of smelted residues from crucibles found near workshops indicates a deliberate effort to recover metal from previously used objects, often involving multiple stages of refinement to remove impurities. In Mycenaean Greece, similar patterns emerge. Fragments of bronze armor and tools have been identified within the same strata as ingots stamped with royal insignia, suggesting that repurposed materials were integrated into state-controlled production systems. The economic rationale for this practice is starkly evident in regions like the Levant, where access to tin was limited, necessitating a cyclical economy of reuse. Isotopic tracing of bronze artifacts from Ugarit reveals that up to 30% of the metal used in later period tools and weapons originated from recycled materials, a figure corroborated by comparative studies of ore composition in the region. This practice extended beyond utilitarian objects. Even decorative items such as religious figurines were dismantled for their metal content, with remnants found in slag heaps near temple complexes. The labor-intensive nature of this process, requiring skilled smiths to separate alloys, reforge them into standardized shapes, and maintain quality control, suggests that recycling was not a last resort, but an embedded aspect of metallurgical prospect infrastructure. In Mesopotamia, cuneiform records from the Old Babylonian period reference metal recovery guilds, indicating institutionalized systems for collecting and redistributing scrap bronze. These practices highlight a sophisticated understanding of resource management, where the economic value of metal was preserved through technological innovation rather than extraction. The sociological implications are equally profound. The control of recycled materials often fell under the purview of elite classes, reinforcing hierarchies that dictated access to both raw resources and finished goods. In Crete, for instance, Minoan palace archives contain administrative tablets detailing the allocation of repurposed bronze to specific workshops, suggesting a centralized system of oversight. The technological ingenuity required to achieve this, such as the development of fluxes to lower melting points during remelting or the use of molds to standardize new castings, reflects an advanced metallurgical knowledge that predates later historical periods. This evidence challenges the assumption that ancient societies operated with limited technical capacity, instead revealing a complex interplay between material scarcity and adaptive innovation. The recycling economy of the Bronze Age was not a fragmented response to crisis, but a coherent mechanism that shaped trade networks, labor systems, and even cultural production. By examining the physical remnants, slag, ingots, broken artifacts, we uncover a hidden layer of economic strategy that prioritized sustainability over conquest, ensuring the longevity of metal resources in an era where extraction alone could not meet demand. The archaeological record thus serves as both a testament to technological resilience and a blueprint for understanding how ancient economies navigated scarcity through systemic reuse. The controlled distribution of recycled bronze during the Bronze Age was not a passive process, but a meticulously engineered system embedded within the economic frameworks of ancient civilizations. Archaeological evidence from the Aegean region, particularly in sites like Knossos and Mycenae, reveals that centralized authorities, often priestly classes or early bureaucratic entities, oversaw the collection, smelting, and redistribution of scrap metal. These systems were not arbitrary. They were designed to balance regional demands while maintaining political cohesion. For instance, the Minoans employed a network of granaries and storage facilities that doubled as repositories for melted-down bronze ingots, ensuring that materials were allocated based on seasonal agricultural cycles and trade obligations rather than individual wealth accumulation. This practice is corroborated by isotopic analysis of bronze artifacts from Crete, which shows a consistent composition across regions, indicating standardized processing techniques enforced by governing bodies. The economic impact of such control was profound. By centralizing the recycling process, societies could mitigate the risks of localized metal shortages, which were critical in an era where bronze was both a tool of production and a symbol of power. In Mesopotamia, cuneiform records from the Old Babylonian period detail administrative decrees mandating the surrender of obsolete weapons and ceremonial objects to state-run foundries. These mandates were not merely acts of resource management, but also mechanisms of social control, as they discouraged private hoarding and reinforced the authority of the ruling class. The melted bronze was then recast into standardized tools, agricultural implements, or even new weapons, which were distributed to regions deemed strategically vital for defense or expansion. This practice is evident in the uniformity of bronze spearheads found across Assyrian military encampments, suggesting a centralized system of production and distribution rather than decentralized craftsmanship. Technologically, the recycling process required sophisticated metallurgical knowledge. Unlike modern smelting techniques, Ancient societies relied on bloomery furnaces capable of reaching temperatures between 1200 degrees C and 1400 degrees, conditions necessary to separate copper from tin ores without compromising the alloy's integrity. The efficiency of these furnaces was further enhanced by the use of recycled bronze as a base material, which required lower melting points than raw ore. This innovation is particularly notable in the Indus Valley Civilization, where excavations at Mohenjo-Daro uncovered slag heaps containing remnants of both smelted ore and repurposed bronze fragments. These findings suggest that metallurgists had developed empirical methods to determine the optimal ratios of recycled material to virgin ore, ensuring consistency in the final product's durability and utility. The sociological mechanisms underpinning this system were equally intricate. In many cultures, the act of recycling itself carried symbolic weight. For example, in ancient Egypt, bronze statues and religious artifacts were often melted down during periods of political upheaval, a practice that served both practical and ideological purposes. By destroying outdated symbols of power and repurposing them into new forms, rulers could assert their legitimacy while simultaneously addressing material shortages. This duality is exemplified by the Amarna period, where large-scale recycling campaigns coincided with Akhenaten's religious reforms, effectively erasing previous dynastic iconography to replace it with new theological imagery. Equitable access to recycled materials was further ensured through trade agreements and tributary systems. In the Eastern Mediterranean, Phoenician merchants played a pivotal role in distributing bronze ingots across vast networks, from Cyprus, a major source of copper, to the Levant and beyond. These transactions were governed by strict weight standards, as evidenced by the use of standardized weights found in Phoenician trade colonies. Such measures prevented exploitation by intermediaries and ensured that regions receiving recycled materials could integrate them seamlessly into their own production cycles. Similarly, in China's Shang dynasty, oracle bone inscriptions reference metal tributes collected from vassal states, which were then processed in royal workshops before being redistributed to support military campaigns or infrastructure projects. Like the construction of palatial complexes, the controlled distribution of recycled bronze also had long-term implications for economic stability. By preventing the monopolization of metal resources by elite classes, these systems inadvertently fostered a form of early capitalism, where access to materials was contingent on participation in state-sanctioned trade networks rather than personal trade networks. Wealth. This is particularly evident in the Iberian Peninsula, where Tartessian societies developed intricate systems of metallurgical exchange that linked local bronze workshops with Mediterranean markets. The presence of tin ingots from Cornwall in Iberian archaeological layers indicates a sophisticated logistical system that prioritized the equitable flow of materials across continents. In conclusion, the controlled distribution of recycled bronze was a multifaceted mechanism that intertwined technological innovation, economic strategy, and sociological control. By centralizing the recycling process, ancient civilizations not only mitigated the challenges of metal scarcity, but also reinforced their political structures and trade networks. The legacy of these systems is etched into the very fabric of archaeological records, from the standardized weights of Mesopotamian ingots to the melted-down statues of Egypt's Amarna period. This segment underscores a critical truth. The recycling economy of the Bronze Age was not merely an act of survival, but a deliberate, structured endeavor that shaped the trajectory of human development for millennia. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. Metallurgical processes employed during the Bronze Age to recycle bronze artifacts were far more sophisticated than previously assumed, involving a combination of thermal engineering, material classification, and labor organization that mirrored. Early Industrial practices. Archaeological evidence from sites such as Hakia Triada on Crete and the workshops of Mycenae reveals that ancient smiths utilized crucibles made of refractory clay, capable of withstanding temperatures exceeding 1000 degrees, critical for melting bronze alloys without degrading their structural integrity. These furnaces were often constructed using layered stones and charcoal, creating a controlled environment where oxygen flow could be modulated to regulate heat intensity. This level of precision suggests an empirical understanding of metallurgy that predated written records, with knowledge likely transmitted through apprenticeship systems rather than formal documentation. Material sorting played an equally pivotal role in ensuring the quality of recycled bronze. Artifacts were categorized based on their composition, with higher-grade alloys, those containing a greater proportion of tin or arsenic, being prioritized for reuse in tools and weapons requiring durability. Lower-grade materials, often contaminated with impurities from corrosion or prior wear, were repurposed into less critical items such as construction components or decorative elements. This stratification was facilitated by techniques like visual inspection, auditory testing, striking metal to assess resonance, and even early forms of density analysis through water displacement methods. Such practices indicate a deliberate economic strategy, maximizing the utility of limited resources while maintaining standards necessary for societal functions. The implications of these techniques extended beyond metallurgy, influencing trade networks and social hierarchies. The ability to recycle bronze reduced dependence on raw ore extraction, which was both labor-intensive and environmentally disruptive. This efficiency allowed civilizations such as the Minoans and later the Phoenicians to allocate resources toward maritime expansion or architectural projects without exhausting their metal reserves. However, it also created a class of specialized artisans, metal workers and overseers who held significant economic power, as their expertise determined the success of large-scale endeavors. The recycling economy thus became intertwined with technological innovation, creating a feedback loop where advancements in furnace design or alloy refinement spurred further economic activity. By repurposing discarded objects into new forms, ancient societies not only mitigated scarcity, but also embedded layers of meaning within their material culture, transforming remnants of war and worship into instruments of progress. The economic implications of bronze recycling during the Bronze Age extended far beyond local metallurgical workshops, fundamentally reshaping trade networks across Eurasia. As societies increasingly relied on repurposed metal rather than newly extracted ores, the demand for raw copper and tin, key components of bronze, diminished in certain regions while intensifying in others. Archaeological evidence from the Aegean and Near East reveals a shift in trade dynamics. Regions with limited access to high-purity copper ores, such as parts of Anatolia and the Levant, began prioritizing the acquisition of scrap bronze objects over raw materials. This transformation is evident in the distribution of tin ingots found at sites like Uluburun in modern-day Turkey, where maritime trade networks facilitated the exchange of recycled metal fragments alongside other goods. The reuse of bronze artifacts also altered economic power structures. Rather than being dominated by mining elites, societies with advanced recycling capabilities, such as the Mycenaeans, gained influence through their ability to refine and redistribute metal resources. This practice reduced the need for long-distance copper imports from sources like Cyprus, which had previously been a cornerstone of Bronze Age trade. Instead, surplus bronze items were melted down in centralized foundries, allowing states to control production and standardize weights and measures for coinage or tools. The economic value of recycled bronze became intertwined with administrative systems, as evidenced by the careful documentation of metal stocks in Mesopotamian temple records. By repurposing weapons, statues, and ceremonial objects into agricultural tools or building materials, Societies not only mitigated scarcity, but also created new markets for secondary products. This shift fostered a more resilient economic model, where recycling became a strategic asset rather than a last resort. However, the reliance on recycled metal also introduced vulnerabilities. Prolonged conflicts that destroyed bronze artifacts could destabilize local economies, as seen in the decline of some late Bronze Age city-states following invasions. The technological mastery required to refine recycled bronze, often involving crucible furnaces and slag analysis techniques, further reinforced social hierarchies, with specialized metallurgists holding significant economic sway. Ultimately, the recycling economy of the Bronze Age demonstrates a sophisticated interplay between resource scarcity, innovation, and trade, laying the groundwork for later economic systems that would dominate the Iron Age. This mechanized approach to material reuse underscores how ancient societies navigated environmental constraints through ingenuity, ensuring their survival in an era defined by metal's transformative role. The environmental impact of Bronze Age recycling practices cannot be overstated when considered through the lens of resource management and ecological preservation. Unlike modern industrial societies, which often prioritize short-term economic gains over long-term sustainability, ancient civilizations faced a direct and immediate consequence of overmining: the irreversible depletion of finite ore deposits. By repurposing bronze artifacts, statues, weapons, tools, through metallurgical processes, these societies effectively mitigated the need for large-scale extraction of copper and tin, the primary components of bronze alloy. This practice not only conserved topsoil integrity, but also minimized deforestation and soil erosion associated with mining operations. Archaeological evidence from sites across the Mediterranean and Near East reveals that regions practicing systematic recycling exhibited significantly less landscape fragmentation compared to contemporaneous areas reliant on unregulated mining. The energy required to melt down existing bronze objects, rather than extract and refine raw materials, further reduced environmental strain. This method of resource reuse demonstrates an early form of circular economy principles, where waste was not discarded, but reintegrated into production cycles. For instance, the recycling of ritualistic bronze vessels in Minoan Crete allowed for the continuous repurposing of metal without depleting local copper reserves. Such practices suggest that ancient societies understood the finite nature of their resources and implemented technological solutions to extend material life cycles. The absence of widespread environmental degradation in Bronze Age settlements, contrasted with later periods marked by resource exhaustion, underscores the efficacy of these recycling strategies. By prioritizing metallurgical efficiency, these civilizations not only sustained economic productivity, but also ensured ecological resilience for subsequent generations. This approach to resource management, driven by necessity rather than ideology, offers a compelling case study in pre-modern sustainability. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. The metallurgical strategies employed during the Bronze Age were not merely technical solutions to material scarcity, but catalysts for a profound socio-political transformation. As bronze artifacts, statues, weapons, and tools were systematically dismantled and repurposed, societies that institutionalized this practice created a feedback loop between resource management and centralized authority. In regions such as the Aegean Basin, archaeological evidence reveals that fragmented ceremonial objects were often melted down in state-controlled workshops, their recycled metal redirected toward military production or a light consumption. This process reinforced hierarchies by concentrating access to raw materials within ruling classes, who could then dictate terms of trade and labor extraction. Consider the case of Mycenaean Greece, where linear B-tablets document the systematic allocation of bronze ingots to specific workshops. indicating a bureaucratic infrastructure that prioritized strategic reuse over cultural preservation. Such practices did not merely conserve resources. They embedded economic power within administrative elites who could manipulate supply chains to consolidate influence. The act of recycling itself became a political tool. By destroying public monuments or repurposing religious artifacts, rulers could erase symbolic legacies of rival factions while simultaneously demonstrating their control over both material and ideological domains. Conversely, societies that failed to establish efficient recycling systems faced destabilization. In parts of the Levant where fragmented communities lacked centralized coordination, bronze scarcity led to increased warfare over remaining resources, fragmenting social cohesion. The disparity between regions highlights how metallurgical practices were not passive adaptations, but active mechanisms for power redistribution. Technologically, the refinement of smelting techniques during this period, such as the use of fluxes to purify recycled metal, enabled high-quality production, further entrenching the economic value of controlled recycling networks. These advancements created a class of specialized artisans whose expertise was indispensable, yet their status remained subordinate to elites who controlled access to raw materials. The result was a stratified society where technological innovation served as both a means of survival and a vehicle for reinforcing existing hierarchies. In essence, the Bronze Age recycling economy functioned as a socio-technical system that intertwined material scarcity with social stratification. By transforming discarded artifacts into instruments of power, societies not only extended the lifespan of finite resources, but also reshaped their internal structures, ensuring that those who mastered metallurgical reuse became the architects of all. Political and economic dominance. This dynamic underscores the intricate relationship between technological capability and societal organization, a legacy that continues to echo in historical narratives of resource management and power consolidation. The recycling systems of the Bronze Age were not uniform. They evolved in response to geographical, technological, and socio-economic contexts. In Mesopotamia, cuneiform records from the Old Babylonian period reveal a centralized approach to metal reuse. Workshops in cities like Ur and Nippur systematically collected bronze artifacts, broken weapons, ceremonial objects, and tools for smelting. These operations were often state-controlled, reflecting the administrative complexity required to manage large-scale recycling. Archaeological evidence, such as slag deposits near temple complexes, suggests that melted bronze was repurposed into new weapons or agricultural implements, reinforcing centralized power structures. The efficiency of this system relied on access to wood fuel for smelting and a labor force trained in metallurgical techniques. In contrast, ancient Egypt's recycling practices were deeply intertwined with religious ideology. Bronze statues and ceremonial objects from the New Kingdom period were frequently melted down not for utility, but to create new deities or repurpose materials into gold-alloyed artifacts. This practice was documented in temple inscriptions that emphasized the transformation of divine metals, a concept tied to Egyptian cosmology. However, this approach often led to inefficiencies. Fragmented records from the 15th century BCE indicate that some bronze items were discarded rather than recycled due to ritual impurities deemed incompatible with reuse. The economic impact was significant. While centralized Mesopotamian systems maximized resource recovery, Egypt's religious constraints limited the scale of recycling. The Indus Valley civilization presented a different model. Excavations at Mohenjo-Daro and Harappa reveal that bronze tools and ornaments were often repurposed into construction materials or trade goods without formal state oversight. The absence of centralized workshops suggests a decentralized approach driven by local communities. Metallurgical analysis of slag from these sites indicates that lower temperature smelting techniques were used, possibly due to limited fuel availability. This method while less efficient than Mesopotamian high-heat furnaces, allowed for the recycling of smaller artifacts into utilitarian objects like agricultural tools. The economic impact was notable. By redistributing bronze within urban networks, the Indus Valley mitigated metal scarcity without relying on state control. In China, early Shang Dynasty, c. 1646 BCE, metallurgical practices reveal a sophisticated approach to alloy management. Archaeological findings from Anyang include bronze vessels and weapons that were deliberately designed for disassembly and reuse. The use of tin-bronze alloys, which degrade more slowly than arsenical bronzes, allowed for longer lifespans in objects like ritual ding vessels. These items were often melted down, not just for their metal content, but to recover precious tin, a scarce resource in the region. This practice was facilitated by advanced crucible technology, enabling precise control over melting temperatures and alloy composition. The economic efficiency of this system is evident in the continuity of bronze production across dynastic transitions, with recycled materials forming the basis of new artifacts. The Mediterranean world, particularly the Aegean and Mycenaean cultures, demonstrated a hybrid model influenced by both trade networks and local traditions. Linear B tablets from Pylos document the redistribution of bronze tools and weapons among ruling elites, suggesting that recycling was a mechanism for consolidating power rather than purely economic survival. However, metallurgical studies of Greek pottery and tools indicate that smaller-scale recycling was common in rural settlements, where melted bronze was used for everyday items like pins or cooking utensils. The efficiency of these systems varied. Coastal regions with access to maritime trade could import raw materials, reducing the need for large-scale recycling, while inland communities relied heavily on reprocessing local artifacts. Across all these cultures, the scale and efficiency of recycling were shaped by resource availability. In regions with abundant timber, such as Mesopotamia's riverine plains, high-temperature smelting was feasible, enabling extensive metal reuse. Conversely, arid regions like Egypt faced fuel limitations, which constrained the volume of bronze that could be processed. Technological innovation also played a critical role. The development of bellows in China and crucible technology in the Indus Valley allowed for more precise recycling processes compared to the open-air furnaces used in the Aegean. Socio-economic structures further influenced these systems. In hierarchical societies like Mesopotamia and Egypt, recycling was often monopolized by elites or religious institutions, which limited access to metal resources for lower classes. By contrast, the relatively egalitarian urban planning of the Indus Valley allowed broader participation in recycling networks, though this may have been offset by less advanced metallurgical techniques. In China, the balance between state control and local innovation created a system where recycled bronze could be both a tool of governance and a medium for cultural continuity. The economic impact of these practices was profound. Recycling reduced reliance on new ore extraction, which was labor-intensive and environmentally disruptive in regions with limited mining access. In Mesopotamia, this allowed cities to sustain large populations without exhausting local resources. However, the reprocessing of bronze often led to a gradual decline in artifact quality over time, as repeated melting introduced impurities that degraded alloy strength. This is evident in later periods, where Egyptian and Mycenaean artifacts show increased fragility compared to their earlier counterparts. Comparative analysis also reveals how trade influenced recycling systems. The Mediterranean's extensive maritime networks enabled the movement of recycled bronze across regions, creating a form of metallic currency that facilitated economic exchange without reliance on coinage. In contrast, landlocked civilizations like those in the Indus Valley relied on localized redistribution, which limited the scope but ensured stability within regional economies. Ultimately, these systems reflect the ingenuity of Bronze Age societies in addressing metal scarcity through technological adaptation and socio-economic organization. While no single model was universally superior, each civilization's approach to recycling was a product of its unique environmental and cultural conditions. These practices not only sustained ancient economies, but also laid foundational principles for resource management that echo through later historical periods. The role of discarded artifacts in Bronze Age recycling practices reveals a sophisticated interplay between material necessity and economic strategy. When bronze statues, tools, or weapons reached the end of their functional lives, they were not abandoned, but systematically repurposed through smelting processes that extracted pure copper and tin alloys. This practice was particularly critical in regions where natural metal deposits were sparse or inaccessible, such as the Aegean Basin or the Levant, where civilizations like the Minoans and Mycenaeans relied on imported ores. The melting of ceremonial artifacts, such as the iconic bronze swords of Ur or the votive statues from Çatalhöyük, illustrates how cultural objects were dismantled to feed the demand for metal in construction projects, agricultural implements, or even military production during periods of conflict. Archaeological evidence from sites like Hattusa and Knossos shows that fragmented bronze items were often collected by centralized authorities or guilds specializing in metallurgy. These groups employed techniques such as flux-based smelting to separate impurities from the metal, a process that required precise temperature control and knowledge of ore composition. The resulting molten bronze was then cast into molds, allowing for the rapid production of standardized tools or weapons. This system not only conserved scarce resources but also created an economic feedback loop. Surplus metal from recycled artifacts could be traded as bullion, fueling long-distance commerce networks that connected the eastern Mediterranean to Anatolia and Mesopotamia. The sociological implications of this practice are equally profound. The destruction of religious or symbolic artifacts for utilitarian purposes suggests a pragmatic approach to resource management that prioritized survival over preservation of cultural heritage. In some cases, entire temples or palatial complexes were dismantled during periods of crisis, with their bronze components melted down to fund military campaigns or urban expansion. This process was not without consequence. The loss of such artifacts disrupted ritual practices and hierarchies, forcing societies to reconfigure their relationships with both material wealth and spiritual symbolism. Technologically, the Bronze Age recycling economy relied on innovations in furnace design and alloy manipulation. For example, the use of tuyères, tube-like structures inserted into furnaces to increase airflow and raise smelting temperatures enabled more efficient metal extraction. This advancement allowed societies to process lower quality ores or recycled materials that would have otherwise been deemed unusable. The resulting bronze, while sometimes inferior in purity to newly mined ore, was sufficient for most practical applications, demonstrating an early understanding of material economics and trade-offs between quality and quantity. The economic impact of this system is evident in the distribution of bronze artifacts across regions. In areas with limited access to raw materials, such as the Italian peninsula or the Iberian coast, recycled metal became a cornerstone of local industries. Shipbuilding, for instance, relied heavily on repurposed bronze fittings and fastenings, while urban centers used melted-down tools to produce new ones in response to labor demands. This practice also influenced social stratification. Control over recycling networks often concentrated power in the hands of elites who could dictate the flow of metal resources, reinforcing existing hierarchies or creating new forms of economic domination. In contrast, regions with abundant natural ores, such as the Carpathian Basin or the Iranian Plateau, developed distinct approaches to recycling. Here, the emphasis was less on salvaging discarded artifacts and more on refining imported metals through advanced smelting techniques. This divergence highlights how environmental conditions shaped technological priorities, with societies in metal-scarce regions innovating more aggressively in recycling methods, while those with rich deposits focused on expanding extraction capabilities. The role of artisanship in this process cannot be overstated. Skilled metallurgists were essential to the success of recycling initiatives, requiring both technical expertise and an understanding of market demands. In some cases, these artisans formed guilds that regulated the quality of recycled bronze, ensuring it met standards for use in construction or warfare. Their work also blurred the line between utility and artistry. Repurposed bronze often retained intricate designs from its previous form, suggesting a deliberate effort to preserve aesthetic value even as function was prioritized. The environmental impact of this recycling economy is another critical dimension. By reducing reliance on newly mined ores, societies minimize ecological disruption associated with large-scale extraction. However, the energy required for smelting and casting still placed significant demands on fuel resources, often leading to deforestation or the overexploitation of charcoal-producing woodlands. This paradox, conserving one resource while depleting another, underscores the complex trade-offs inherent in ancient technological systems. Finally, the legacy of Bronze Age recycling practices extends beyond their immediate economic and technical contexts. The principles of material reuse and resource optimization laid a foundation for later metallurgical traditions, influencing everything from Roman coinage production to medieval blacksmithing techniques. By examining these processes, we gain insight into how early civilizations navigated scarcity, not through conquest or depletion, but through innovation, collaboration, and an acute awareness of their relationship with the materials that shaped their relationship with the materials. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. Technological advancements in Bronze Age metallurgy represent a critical juncture in the evolution of resource management during an era defined by metal scarcity. Central to this transformation was the refinement of furnace designs, which allowed for more controlled and efficient smelting processes. Early furnaces, often rudimentary pits or open-air structures, lacked the capacity to sustain high temperatures necessary for melting bronze consistently. However, innovations such as the introduction of tuyères, tubular air ducts inserted into furnace walls, enabled a more directed flow of oxygen-rich air, significantly increasing combustion efficiency. These modifications elevated peak furnace temperatures by up to 200 degrees C compared to earlier methods, reducing the energy required to melt bronze and minimizing the loss of valuable alloys during recycling. Archaeological evidence from sites like Hattusa in Anatolia reveals layered furnace remains with distinct refractory linings composed of clay mixed with crushed quartz, a technique that prolonged thermal retention and reduced wear on furnace structures. This advancement not only improved the yield of recycled metal, but also allowed for the simultaneous processing of multiple artifacts, accelerating the rate at which bronze could be repurposed into tools, weapons, or construction materials. Parallel to furnace innovations were developments in material sorting methodologies, a process crucial to maintaining the integrity of recycled alloys. Bronze, an alloy primarily composed of copper and tin, required careful segregation to ensure consistent composition in new castings. Early recycling efforts often resulted in inferior products due to contamination from varying tin content in discarded items. To address this, metallurgists adopted systematic sorting practices based on visual and tactile cues, such as the luster or weight of artifacts, which correlated with their copper-to-tin ratios. In some regions, such as the Levant, evidence suggests the use of sieves and grading tables to separate fragmented bronze pieces by size, while more advanced workshops employed flux agents, substances like charcoal or limestone, to purify molten metal. By removing impurities during smelting, this precision in sorting directly influenced the quality of recycled bronze, enabling the production of standardized tools and weapons that rivaled newly mined materials. The economic implications were profound. By reducing reliance on tin imports, a resource often controlled by distant trade networks, civilizations could mitigate vulnerabilities tied to supply chain disruptions. For instance, the Mycenaeans' ability to recycle bronze from war booty and ceremonial objects may have sustained their military dominance during periods of restricted access to Anatolian tin sources. These metallurgical innovations did not exist in isolation, but were part of a broader socio-economic framework that prioritized resource conservation. The increased efficiency of recycling processes meant that societies could extract more usable metal from each batch of discarded artifacts, reducing the need for large-scale mining operations. This had cascading effects on labor distribution, as fewer workers were required to extract raw materials, allowing communities to redirect human capital toward other economic activities such as agriculture or trade. Additionally, the standardization of recycled bronze products facilitated the emergence of early market systems where uniformly produced tools and weapons could be exchanged with predictable value. The presence of recycled bronze ingots in hordes across the Aegean and Near East suggests that these materials were not merely repurposed locally, but circulated as commodities within trade networks, reinforcing the interconnectedness of Bronze Age economies. By the late Bronze Age, metallurgical techniques had advanced to the point where recycled bronze could be refined to such a degree that it was indistinguishable from newly cast metal in terms of structural integrity. A technical achievement underscored the ingenuity of ancient engineers in addressing the challenges of metal scarcity through innovation rather than extraction. The economic implications of bronze recycling during the Bronze Age reveal a sophisticated approach to resource management that transcended mere survival strategies. By repurposing discarded or damaged artifacts, societies mitigated the volatility of external trade dependencies, which were often disrupted by geopolitical conflicts or environmental shifts in mining regions. For instance, evidence from Minoan Crete suggests that fragmented bronze weapons and ceremonial objects were systematically collected and melted down for reuse in tools and infrastructure projects, a practice that minimized the need to acquire new copper or tin through costly long-distance trade networks. This internalized resource cycle allowed communities to maintain economic continuity even during periods of scarcity, as the value of recycled metal remained intrinsically tied to its utility rather than fluctuating market prices. The process also fostered specialized labor divisions, with metallurgists developing techniques to refine scrap bronze into high-quality alloys suitable for new applications, thereby enhancing productivity and reducing waste. In regions like the Near East, where tin, a critical component of bronze, was scarce, recycling became a strategic economic measure, enabling states to sustain military production and urban development without exhausting finite reserves. Furthermore, the act of dismantling and reprocessing artifacts may have carried symbolic significance, reflecting societal priorities that shifted from ostentatious displays of wealth to pragmatic resource allocation during crisis. This adaptive economy, rooted in metallurgical ingenuity, underscored a fundamental principle: the ability to transform existing materials into functional assets was as vital to ancient economies as the initial extraction of raw metals. By embedding recycling into their economic frameworks, these societies not only preserved material wealth, but also cultivated resilience against the inherent unpredictability of natural and human systems. a legacy that continues to inform modern systems. Discussions on sustainability and resource management. Recycling of bronze artifacts during the Bronze Age was not merely a pragmatic response to metal scarcity. It became deeply embedded in the sociocultural fabric of ancient societies. In regions such as the Eastern Mediterranean and Anatolia, where access to tin, a critical component of bronze, was limited by geographic and political barriers, the reuse of existing bronze objects carried symbolic weight. Archaeological evidence from sites like Hattusha in the Hittite Empire reveals that fragmented statues and ceremonial weapons were frequently melted down and repurposed into tools, agricultural implements, or even new religious iconography. This practice was not seen as a degradation of value, but rather as an act of continuity, reflecting a worldview where materials were understood to possess intrinsic worth beyond their immediate utility. In Mesopotamian contexts, for instance, the reworking of bronze temple vessels into trade goods underscored economic adaptability while reinforcing the idea that divine favor could be channeled through material transformation. The technical precision required to refine recycled bronze, often involving slag analysis and controlled smelting, suggests that metallurgical specialists held a revered status, their work mediating between spiritual symbolism and practical necessity. By examining the microstructure of recycled bronze objects from Ur and Knossos, modern researchers have identified deliberate alloy adjustments, indicating that ancient artisans were not merely recycling, but innovating, modifying compositions to enhance durability or aesthetic qualities. This duality of resourcefulness as both a survival strategy and a cultural statement reveals how metallurgical practices during the Bronze Age were inextricably linked to societal values, with recycled artifacts serving as tangible records of economic resilience and technological ingenuity. The act of dismantling an old bronze sword to forge a plowshare, for example, was not merely a transaction of materials, but a ritualized assertion of human agency over nature's constraints, embedding within each repurposed object the accumulated knowledge and priorities of its society. Such practices highlight a sophisticated understanding of material cycles that predated modern environmental discourse by millennia, demonstrating that the Bronze Age was not an era of primitive scarcity, but one of calculated innovation, where one of foreign cultural identity and economic survival were forged through metallurgical mastery. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. The metallurgical sophistication of the Bronze Age recycling economy becomes starkly evident when examining the chemical signatures preserved within recycled bronze artifacts. Scientific analyses, particularly through X-ray fluorescence and isotopic tracing, have uncovered that up to 75% of certain bronze objects, such as late Bronze Age tools from Mycenaean sites or ceremonial weapons from Hittite workshops, contain reprocessed metal. This high proportion of recycled material suggests a deliberate and systematic approach to resource management, where societies did not merely melt down old items for raw material, but actively curated the properties of their alloys. The consistency in tin and copper ratios across multiple generations of artifacts indicates an advanced understanding of how metal composition could be maintained or modified during remelting. Such practices required precise control over furnace temperatures, slag formation, and alloy segregation, techniques that imply specialized metallurgical knowledge transmitted through guilds or family lineages. Furthermore, the presence of trace elements from disparate geographic sources within single artifacts hints at a networked economy where recycled materials were traded across regions, blending local and imported metals into new forms. This challenges the notion of the Bronze Age as a period of primitive resource use, Instead, it reveals an early form of industrial recycling where metal scarcity was met not with depletion, but with innovation. The economic implications are profound. By reusing bronze, societies reduced their dependence on mining and long-distance trade for raw materials, stabilizing local economies while minimizing the risks associated with supply chain disruptions. However, this practice also created a paradox. While recycling preserved material wealth, it simultaneously erased historical records encoded in original artifacts, such as inscriptions or decorative motifs, which were often lost during remelting. The sociological dimensions of this system are equally revealing. The act of dismantling and reworking bronze objects may have carried symbolic weight, reflecting cultural attitudes toward legacy and renewal. In some cases, entire statues or religious icons were repurposed into utilitarian items, suggesting a pragmatic approach to material culture that prioritized function over tradition. This duality, economic efficiency clashing with the erasure of historical identity, underscores the complexity of Bronze Age societies, where technological ingenuity was both a tool of survival and a force reshaping cultural memory. The persistence of recycled bronze across millennia further attests to its durability and the value placed on metallurgical continuity, demonstrating that the Bronze Age economy was not merely reactive to scarcity, but proactively engineered to sustain itself through cycles of destruction and rebirth. The military production of the Bronze Age was inextricably tied to the metallurgical capacity of societies to recycle existing bronze stockpiles. Archaeological evidence from Mycenaean Greece reveals that over 70% of weapons unearthed in late Bronze Age contexts contained recycled metal, indicating a systematic approach to repurposing spent armor and broken tools. This practice was not merely a response to scarcity, but a calculated economic strategy. The energy required to melt down existing bronze artifacts, often discarded as damaged or obsolete, was far less than extracting new copper and tin ores from difficult-to-access sources. Smelting workshops in regions like Crete and the Levant developed specialized furnaces capable of reaching temperatures exceeding 1200 degrees C, necessary for refining bronze without compromising its alloy integrity. These facilities were often located near urban centers, ensuring proximity to labor forces and administrative control over resource distribution. The process involved meticulous sorting of scrap materials. Broken weapons were separated by alloy composition, while ceremonial objects, such as statues or religious paraphernalia, were sometimes melted en masse due to their lower intrinsic value. Compared to military-grade bronze, the economic implications of this recycling infrastructure were profound. By maintaining a steady supply of usable metal, societies could sustain large-scale production of spearheads, swords, and scale armor without relying on new mining operations. This efficiency allowed city-states like Knossos to field armies that outpaced their neighbors in both quantity and quality of weaponry. However, the practice also introduced sociological tensions. The destruction of symbolic artifacts, such as votive offerings or royal regalia, often sparked resistance from elite classes who viewed such acts as desecration. In some cases, recycled bronze was marked with distinct stamps or inscriptions to denote its origin, a practice observed in Hittite and Assyrian foundries. These markers suggest an early form of metallurgical accountability, ensuring that recycled materials met military specifications. The integration of scrap metal into new weapons also required advanced casting techniques. Artisans employed lost wax methods to recreate intricate patterns on repurposed blades, masking the origins of the material while preserving its functional properties. The most striking example of this system's scale appears in the Aegean region, where analysis of bronze ingots recovered from shipwrecks shows a consistent pattern of reprocessing. These ingots, often stamped with standardized weights and symbols, were traded across networks stretching from Anatolia to Egypt, indicating that recycling was not only a local practice, but a cornerstone of interregional economic coordination. By the late Bronze Age, this system had evolved into a near-industrialized process, with dedicated labor forces, controlled supply chains, and technical innovations that would not be replicated until the advent of modern metallurgy. The ability to sustain military production through recycling ultimately determined the longevity of Bronze Age civilizations, as those who mastered the technique outcompeted rivals, unable or unwilling to embrace the resourcefulness required by metal. Scarcity. The economic ramifications of recycled bronze usage during the Bronze Age extended far beyond local metallurgical workshops, reshaping trade networks across vast regions. By repurposing existing bronze artifacts, ranging from ceremonial weapons to corroded tools, societies minimized reliance on extracting and transporting raw copper and tin ores over long distances. This shift reduced logistical burdens associated with maritime or overland conveyance of heavy, high-value materials, which were often subject to theft, spoilage, or environmental degradation during transit. Instead, regions could redirect resources toward refining and redistributing recycled metal, a process that required less energy and infrastructure compared to mining operations. Archaeological evidence from the Aegean Basin reveals isotopic signatures in bronze artifacts that trace their origins to locally melted down objects rather than newly mined ores, underscoring a deliberate economic strategy. This practice fostered interregional trade by creating demand for standardized recycled alloys, which could be more efficiently produced and transported than irregular ingots of raw metal. For instance, the Mycenaeans leveraged this system to maintain consistent quality in their weaponry and tools, enabling them to sustain military campaigns without exhausting finite ore reserves. Additionally, the ability to melt down obsolete items, such as broken statues or outdated ceremonial objects, allowed societies to reallocate resources toward emerging economic needs, such as coinage or architectural embellishments. This circular economy model not only mitigated metal scarcity but also encouraged technological innovation in smelting techniques, as artisans refined methods to extract pure copper and tin from heavily oxidized scrap. The reduction in raw material trade also diminished the strategic importance of certain geographic regions that had previously monopolized access to key ore deposits, redistributing economic power more evenly across networks. In Mesopotamia, for example, the reuse of bronze tools facilitated agricultural expansion without necessitating new mining expeditions, while Anatolian merchants capitalized on the demand for recycled metal by establishing specialized workshops along trade routes. These dynamics reveal a sophisticated understanding of resource management, where recycling became a cornerstone of economic resilience rather than a desperate measure against scarcity. The efficiency gains from this system allowed civilizations to allocate surplus labor and capital toward other endeavors, such as urban development or administrative infrastructure, thereby reinforcing the interconnectedness of Bronze Age economies. By prioritizing the reuse of metal artifacts, ancient societies not only conserved finite resources, but also laid the groundwork for trade systems that emphasized value retention over extraction, a principle that would echo through subsequent eras of technological and economic evolution. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. The social frameworks underpinning Bronze Age recycling economies were deeply entwined with hierarchical governance, where metallurgical control became a cornerstone of political authority. Centralized administrations, often embodied in palace complexes or temple institutions, established bureaucratic networks to oversee the collection, processing, and redistribution of scrap metal. In regions like the Near East, cuneiform records from Mesopotamian city-states reveal systematic quotas for bronze submission by artisans and landowners, ensuring a steady influx of material for state-sponsored workshops. These systems were not merely logistical, but served as mechanisms of power consolidation, with elites leveraging control over metallurgical resources to enforce economic dependency among subject populations. The logistical infrastructure required for such operations necessitated specialized labor divisions. Smelters, mold makers, and transport overseers formed distinct occupational classes, their roles codified in administrative texts. In the Aegean, linear B tablets from Mycenaean palaces document the allocation of recycled bronze to specific military or construction projects, illustrating how resource management was weaponized to sustain both warfare and monumental architecture. The melting down of ceremonial artifacts, such as the repurposing of Minoan religious statues into tools or weapons, underscored a pragmatic worldview where symbolic value yielded to material utility, reflecting broader socio-cultural priorities. Economic stability within these systems hinged on the balance between centralized control and localized autonomy. Regional governors or temple officials often acted as intermediaries, collecting scrap metal from villages and redistributing refined bronze in exchange for agricultural surpluses or labor obligations. This reciprocal relationship mitigated resource hoarding while embedding metallurgical expertise within local power structures. However, disparities emerged where access to recycling networks favored urban elites over rural communities, exacerbating socio-economic stratification. The technological demands of large-scale recycling further shaped social hierarchies. Advanced furnaces capable of melting high-temperature bronze required specialized knowledge, restricting smelting operations to elite-controlled sites. In the Levant, archaeological evidence from Ugarit shows that metal workers were housed in compound structures adjacent to administrative centers, their labor directly supervised by scribes and military officials. This spatial arrangement reinforced the integration of metallurgy with state functions, ensuring that recycled bronze remained a tool of governance rather than a commodity for private accumulation. By institutionalizing recycling as a state-managed process, Bronze Age societies circumvented the depletion of finite metal reserves while embedding economic interdependence into their social fabric. The meticulous record-keeping of scrap metal flows, whether in the form of Mesopotamian temple inventories or Hittite royal decrees, demonstrates an early form of resource accounting that prefigured later fiscal systems. Yet, this centralization also created vulnerabilities. Disruptions to administrative networks, such as those caused by invasions or trade collapses, could precipitate cascading failures in metal supply chains, underscoring the fragility of these fees. Seemingly robust systems, the long-term sociological impact of these recycling economies lay in their normalization of material reuse as a cultural imperative. Unlike later periods where metal scarcity spurred innovation, Bronze Age societies often viewed recycling not as an economic necessity, but as an intrinsic aspect of resource stewardship. This mindset was codified in legal codes and religious texts, which mandated the return of worn tools or broken weapons to communal workshops for remelting, a practice that blurred the lines between individual ownership and collective responsibility. Such norms ensured that metal remained a circulating asset within the economy rather than a fixed property, reinforcing the interdependence between social cohesion and metallurgical survival. Ultimately, the centralized management of recycling systems during the Bronze Age reveals an intricate relationship between technological capability, economic strategy, and political power. By embedding metallurgy within administrative hierarchies, ancient civilizations not only mitigated resource scarcity, but also constructed a framework where material flow became a proxy for social control. This legacy endured in subsequent eras, laying the groundwork for more formalized systems of resource management that would emerge in the Iron Age and beyond. The recycling economy of the Bronze Age was not merely an exercise in resource management. It was a deliberate strategy to mitigate environmental degradation, while maintaining metallurgical output. Archaeological evidence from the Aegean region reveals that societies such as those of Mycenae and Crete systematically repurposed bronze artifacts, reducing reliance on newly mined ores by up to 40% during periods of peak demand. This practice minimized deforestation rates associated with mining operations, which required vast quantities of timber for smelting furnaces. By melting down ceremonial weapons, ornamental objects, and even damaged tools, these civilizations effectively closed the loop between production and consumption, a concept eerily similar to modern circular economies. The ecological footprint of bronze extraction in the eastern Mediterranean was immense. Copper mines on Cyprus, one of the primary sources of ore during the late Bronze Age, show signs of overexploitation, including soil erosion and altered river courses caused by hydraulic mining techniques. Yet, contemporaneous metallurgical workshops in Syria and Anatolia demonstrate a parallel effort to recycle scrap metal, with slag analysis revealing high concentrations of reprocessed bronze alloys. This suggests that recycling was not only economically prudent, but also a method of conserving the fragile ecosystems surrounding mining sites. The reuse of bronze statues from religious contexts, such as those discovered in the palace complexes of Pylos and Knossos, indicates a societal acceptance of repurposing sacred objects, reflecting a cultural prioritization of utility over symbolism. During times of scarcity, economically, this recycling system functioned as an early form of resource stewardship, ensuring that metal availability remained stable across generations. Trade networks across the Levant and the Aegean were structured to facilitate the redistribution of scrap metal, with merchants specializing in the collection and transportation of broken tools and armor. This created a secondary economy within the broader Bronze Age trade system, where the value of recycled bronze was often comparable to newly produced ingots. In Mesopotamia, cuneiform records from the 14th century BCE detail transactions involving reprocessed metal for temple construction projects, highlighting how religious institutions acted as both repositories and redistributors of recycled materials. Technologically, the process of recycling bronze required advanced metallurgical knowledge. Unlike modern smelting techniques, which rely on precise temperature control, Bronze Age smiths employed charcoal-fed furnaces capable of reaching temperatures between 1200 degrees C and 1300 degrees, sufficient to melt existing bronze objects without compromising their alloy integrity. Analysis of recycled bronze artifacts from the Hittite Empire reveals that artisans often blended old scrap with new ore to maintain desirable properties such as hardness and corrosion resistance. This practice not only extended the lifespan of metal objects, but also allowed for the fine-tuning of alloys, a technique that would not be replicated in industrial contexts until the 19th century. The sociological implications of this system are equally profound. Recycling practices fostered a collective responsibility toward resource conservation, embedding sustainability into the fabric of daily life. In Minoan Crete, for instance, communal workshops were established to process scrap metal, suggesting that metallurgical labor was not confined to elite classes, but involved broader segments of society. This democratization of metallurgy may have contributed to social cohesion as communities collaborated on projects requiring large-scale recycling efforts. Furthermore, the reuse of bronze in construction, such as the reinforcement of palace walls with recycled ingots, demonstrates how economic priorities were intertwined with architectural innovation, ensuring that infrastructure development did not come at the cost of environmental exhaustion. The legacy of these practices is evident in the longevity of Bronze Age civilizations. By prioritizing recycling over unregulated mining, societies such as those of the Shang dynasty in China and the Indus Valley civilization maintained resource stability for centuries. In the Indus Valley, for example, The absence of extensive mining waste near urban centers suggests that metal reuse was deeply integrated into their economic model. This approach allowed these civilizations to avoid the environmental collapse that often accompanies overexploitation, a lesson echoed in contemporary discussions on sustainable resource management. In conclusion, the Bronze Age recycling economy represents one of the earliest instances of large-scale environmental sustainability. By minimizing ecological disruption through metallurgical reuse, ancient societies achieved a balance between technological advancement and planetary stewardship, a principle that remains relevant in addressing modern challenges of resource depletion and climate change. The ingenuity of these early civilizations lies not only in their mastery of metalworking, but also in their ability to envision long-term consequences, embedding resilience into both their economies and ecosystems. Recycling economy of the Bronze Age was not merely an act of necessity, but a sophisticated system embedded in the socio-technological fabric of early civilizations. Archaeological evidence from sites across the Mediterranean and Near East reveals that societies such as those of Mycenaean Greece, the Hittites, and the Levant developed intricate methods for reclaiming bronze, primarily an alloy of copper and tin, from discarded artifacts. This process involved not only the physical act of melting down statues, weapons, and tools, but also a structured economic framework that dictated who controlled the recycling process, how materials were distributed, and what forms of value these recycled metals retained. For instance, in regions where tin was scarce, the reuse of bronze objects became a critical mechanism for sustaining trade networks, as repurposed metal could be re-exported as raw material or transformed into new goods. The technological precision required to separate copper from tin during smelting, a process involving high-temperature furnaces and fluxes, suggests that metallurgical knowledge was deliberately preserved and transmitted across generations. This practice created a closed-loop system where the economic value of bronze was not diminished by its reuse, but rather reinforced through its adaptability. Visual prompts. 1. A reconstructed Bronze Age furnace with slag residue. 2. A fragmented statue being dismantled from metal extraction. 3. A schematic of early smelting techniques. 4. A merchant weighing recycled bronze ingots on a balance scale. The sociological implications of such recycling systems extended beyond metallurgy, influencing power dynamics and labor organization. In many Bronze Age societies, the control of metal resources was concentrated in elite classes or specialized guilds, who monopolized both the production of new artifacts and the reclamation of old ones. This created a hierarchy where access to recycled materials became a marker of status, as seen in the reuse of royal regalia or ceremonial weapons into more utilitarian objects for military or economic purposes. For example, excavations at the site of Hattusa, the Hittite capital, have uncovered evidence of bronze tools and armor that were repurposed from earlier religious statues, indicating a deliberate policy of resource allocation tied to political authority. Additionally, the labor involved in recycling, such as the manual breaking down of artifacts or the labor-intensive process of refining metals, was often delegated to lower classes, reinforcing social stratification. This system mirrors modern industrial practices where material reclamation is both an economic strategy and a socio-political tool. Visual prompts. 5. A schematic of Bronze Age social hierarchy with metallurgical roles. 6. Workers breaking down bronze objects in a workshop. 7. A comparison image showing a ceremonial weapon transformed into a farming tool. 8. Elite figures handling ingots in a palace context. Technological innovations in recycling also reflect an early understanding of material science, as evidenced by the analysis of metal isotopes and alloy compositions in recycled artifacts. Studies of bronze objects from the late Bronze Age reveal that artisans often blended recycled metal with newly mined copper to maintain desired properties such as hardness or corrosion resistance. This practice required a nuanced knowledge of metallurgical ratios, which was likely passed down through apprenticeship systems or codified in written records, though such documentation remains elusive due to the perishable nature of many ancient texts. In regions like Cyprus, a major hub for copper production, evidence suggests that workshops employed standardized methods for assessing the purity of recycled bronze, ensuring consistency in new products. These practices underscore a level of technical sophistication that challenges assumptions about the limitations of pre-industrial societies. Visual prompts. 9. A close-up of bronze alloy composition analysis. 10. A diagram showing the blending of recycled and raw materials. 11. A Cypriot smelting site with slag heaps and furnaces. 12. Artisans using scales to measure metal proportions. The economic impact of Bronze Age recycling systems cannot be overstated, as they allowed civilizations to mitigate the risks associated with resource scarcity and geopolitical instability. By repurposing existing stockpiles of bronze, societies reduced their dependence on long-distance trade for raw materials, which was often vulnerable to disruption by warfare or natural disasters. This self-sufficiency is particularly evident in the Aegean region, where the reuse of Mycenaean bronzeware during periods of decline suggests a strategic shift toward localized resource management. Furthermore, the commodification of recycled metal created new markets, as broken or worn-out artifacts could be sold as raw material rather than discarded entirely. This practice parallels modern recycling economies, where the value of materials is preserved through secondary markets. However, the Bronze Age system also had limitations. For example, the repeated melting and recasting of bronze could lead to the gradual depletion of tin, a critical but rare component of the alloy. Visual prompts. 13. A map showing trade routes versus localized recycling centers. 14. A market scene with traders exchanging recycled metal. 15. A comparison of intact versus worn-out bronze tools. 16. A chart illustrating the depletion of tin reserves. Over time, the legacy of these ancient systems extends into modern metallurgy and sustainability practices, offering lessons in material efficiency and circular economies. The Bronze Age's emphasis on reusing metals, rather than extracting new ones, aligns with contemporary efforts to reduce environmental impact through recycling. For instance, the smelting techniques used to separate copper from tin have parallels in today's methods for recovering rare earth metals from electronic waste. Additionally, the social structures that governed access to recycled materials mirror modern debates about equity in resource distribution. While ancient societies often restricted recycling to elite classes, contemporary models aim to democratize material reuse through public infrastructure and policy. However, the Bronze Age also highlights the challenges of scaling such systems, namely, the energy required for smelting and the potential degradation of metal quality over successive recycles. These considerations remain relevant as modern industries seek sustainable alternatives to linear consumption models. Visual prompts. 17. A modern recycling plant with similar furnace designs. 18. A graph comparing ancient and modern material reuse rates. 19. A schematic of a circular economy inspired by Bronze Age practices. 20. A researcher analyzing a recycled bronze artifact under a microscope, linking it to contemporary material science. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey.